Yeah, very good evening. So once again, I am recalling this unit commitment problem. That is involved in unit commitment problem by using priority list method. In the priority list method, the first step is you have to determine. Yeah, in the priority list method, the very first step is you have to determine the full load average production cost for the each units. That is FLAPC. Full load average production cost is capital FLAPC is equal to net heat rate characteristics into the fuel cost. The fuel cost is given by small k. So FLAPC is equal to HI of PGI divided by PGI. So what is the next step? Step number 2, form the priority order based on average production cost. Okay, so by using the ascending order you have to sort and you have to form the priority order. Next, commit the number of generating units corresponding to the priority order. So we have to commit the number of generating units corresponding to the priority order. Next, we have to calculate pg1 comma pg2 up to pgn from economic load dispatch problem for the feasible combinations only. Okay, so we have to calculate pg1 pg2 up to pgn for economic dispatch problem for the feasible combinations only. Next, for the load curve, next step, for the load curve, each hour is varying. Assume the load is dropping or decreasing. Okay, assume always the load is dropping or decreasing. Determine whether the dropping the next unit will supply generation and as well as the spinning reserve. Okay, if not, continue as it is. If yes, go to the next step. Next, determine the number of hours h before the unit will be added again. Determine the number of hours h before the unit will be added again. Check capital H is less than minimum shutdown time. Capital H is less than minimum shutdown time. If yes, go to the last step. If not, go to the next step. So calculate these two costs. That is, first one is sum of hourly production cost for next hours H with the unit up. Next, recalculate the same for the unit down startup cost for either cooling or banking. If the second case is less expensive, the unit should be on. Repeat the procedure until the priority list. So these are the steps in the unit commitment problem. Sometimes they may ask the general formulation, derive the general formulation for the unit commitment problem, or what are the steps involved in solving the unit commitment problem by using priority list method. So you have to write all the assumptions. So already we have seen no assumptions like no load cost is zero, unit input output characteristics are linear between zero and full load, startup cost are of fixed amount, then ignore the minimum uptime and minimum downtime constraints. So these are the assumptions used for the solving the unit commitment problem. So after writing the assumptions, we have to write the steps involved in the unit commitment FLAPC problem. Okay. So next thing is that we'll see the merits and demerits of limitations of this priority list method for solving unit commitment problem. So no need to go for n combinations. Okay, so in this main thing is no need for n combinations. Take only one constraints. Okay, in this method we are taking only one constraints. Next is ignore the maximum uptime and maximum downtime. So we have to ignore the maximum uptime and downtime constraints. Next, the complications reduce. Complications reduced. Why? Because we are not going for n combination, and also only one constraint only we are taking into the account, so that so complications is reduced in this particular priority list method for solving unit commitment problem. So what are the limitation? Startup cost are of fixed amount. Okay, startup cost are of fixed amount, but generally it will be not fixed. It might be somewhat varying. So no load costs are not considered. No load costs are not considered. But generally in practical practice, we have to consider the no load cost also. Okay, no load cost also we need to consider. So these are the limitations. These are the limitations. These are the advantages. So what is the major advantages is that, okay, no need to go for n combination. So we are taking only one constraint. Ignore the minimum uptime and downtime constraints. Next, complication of this method can be reduced. Okay, complication of the method is reduced. That is priority list method, for solving by using priority list method is reduced. Next, limitation: startup costs are of fixed amount and no load costs are not considered over here. So these are the limitations. Coming to the problem, so constraints, I think we have already discussed the constraints. So straight away we are going for solving the problem. So what is problem number one? In the problem number one, the given what we have given is determine. What they have given is determine priority list using full load average production cost, that is FLAPC, for the data given below. So the units number, generating units number is being given, that is 1, 2, 3. Then loading limits, minimum and maximum operating loading limits also given. Minimum operating limits, maximum operating limits. I think this is in megawatt. They missed that. Okay, and there's some errors are there. So this is in megawatt. Okay, next is fuel cost function. Fuel cost parameter, that is ABC is given. ABC is given for 3 generating units, and fuel cost for first generating unit, second generating unit, and third generating unit is given. In sometimes, how they will ask is, this fuel cost parameter they will be given as alpha, beta, and gamma, like that. Okay, alpha, beta, and gamma, like that. In some question paper, they some books, if you refer some other books, foreign author books, they will be mentioned like alpha, beta, gamma. So alpha, beta, gamma is nothing but ABC only. So no need of confusing. Okay, so this is ABC. So minimum and maximum loading is given. So for generating unit 1, what is the minimum and maximum megawatt is 100 megawatt to 400 megawatt. Then generating unit 2, 50 megawatt to 300 megawatt. 3, 150 megawatt to maximum of 500 megawatt. So fuel cost function is given 0.006, B is 7, this is C is 600. So A2 is 0.01, B2 is 8, C2 is 400. A3 is 0.008, B3 is 6, then C3 is 500. Then fuel cost for first is 1. First generating unit is 1.1. Then second is 1.2. Third is 1.0. This is given in dollars in this problem. Sometimes fuel cost will be given in rupees also. So based on that, you have to go for. Next, so from this data, we have to frame the heat rate characteristics. Heat rate characteristics from this data we are framing. That is 0.006 Pg1 squared plus 7 Pg1 plus 600. H2 is equal to 0.01 Pg2 squared plus 8 into Pg2 plus 400. Next, H3 is equal to 0.008 Pg3 squared plus 6 Pg3 plus 500. After that, what is the first step? First step is to calculate full load average production cost. Okay, full load average production cost, that is FLAPC I. Ith generating unit is equal to HI of PGI divided by PGI into the fuel cost rupees, that is KI, that is given as KI, where I is equal to 1 to 3, 1 to maximum generating unit N. So here it is given as 3. So I is equal to 1 to 1 comma 2 comma 3. So FLAPC of I, FLAPC I is equal to KI into HI of PGI divided by PGI. This is the general formula, first step. So we have to substitute I is equal to 1 here. So FLAPC of 1. So unit, okay. So you have to substitute what we have substituted. We have substitute PGI is equal to PGI maximum for each unit. So for unit number 1, I is equal to 1. So here we have substituted FLAPC of 1 is equal to K1 into H1 of PG1 divided by PG1. K1 is equal, FLAPC of 1 is equal to K1 into H1 of PG1 divided by PG1. While substituting, we have to substitute PGI is equal to PGI maximum. So here PG1 is equal to PG1 maximum. What is PG1 maximum here from the given table? PG 400. So 400 megawatt you have to substitute here. So we have to substitute PG1 is equal to PG1 maximum. Okay, so so we have to substitute H1 H1 of PG1. So first one is K1. So K1 is 1.1 from the given data. From the given data, K1 is 1.1 here. So K1 we have taken as 1.1. So K1 we have taken as 1.1. H1 of PG1. H1 of PG1 we have already we have taken here. That, yeah, H1 of PG1. So this is H1 of PG1. So here we have to substitute PG1 is equal to 400 megawatt. Okay, while substituting 400 megawatt here, sorry, here it is substituted as 600 megawatt. 600 or 400? Yeah, some mistake happened here. Here it is 600 only. Sorry, PG1 squared is 400 only. Okay, so here it is, maximum generating unit is 400 only. Maybe this data might be wrong. Instead of 600 they may have given us 400 or something. So the correct thing details, the correct thing you just take. So PGI maximum. So PGI maximum, I think here it is printing mistake. So here 600 only, 600, 400 and 500. Instead of that, they printed wrongly this material. So here maximum generation is 600. Okay, 600 you can take. So 600 while substituting, you will get to the value as 11.98. 11.98. Full load average production cost is 11.98. Next for unit number 2, that is I is equal to 2. FLAPC2 is equal to K2 into H2 into PG2 divided by PG2. So by substituting PG2 as PG2 maximum. So PG2 maximum, that is given as 400. So 400 megawatt. So 400 megawatt we have to substitute here. We have to substitute here. K2 is 1.2. 1.2 into that in this generating rate, that is H2. H2 of PG2. That is 0.01 PG2 square plus 8 PG2 plus 400. divided by Pg2 divided by 400. So it will give the answer of 14.8. Again FLAPC3. Again K3. What is K3? That is given. That is 1.0. That is already given. Again H3 of Pg3 divided by Pg3. So H3 of Pg3, here it is given. That is 0.008 Pg3 square plus 6 Pg3 plus 500. So we have to substitute Pg3 is equal to 500 megawatt. Yeah, here 500 megawatt and divided by 500 megawatt into K3. That is 1.0. It will give the answer of, I think, 11. Okay, so we got FLAPC 1, that is 11.99, FLAPC 2 14.8, then FLAPC 3 as 11. Next, what we have to do is we have to sort. First, we have to form the like a priority order. Priority order. So, for forming this priority order, we have to arrange the FLAPC in ascending order. Ascending order means, so first is FLAPC 3, second one is FLAPC 1, and third one is FLAPC 2. So we have to sort in ascending order. So unit, so you have to frame the table like this: unit FLAPC minimum megawatt and maximum megawatt. Minimum megawatt is, sorry, FLAPC of 1. FLAPC of 1 is here. Yeah, so 3 is 11. So we have sorted in ascending order, no? 11, then 11.99, then 14.8. Correspondingly, minimum and maximum megawatt we have to write. Correspondingly, minimum and maximum megawatt is given over here. Minimum and maximum, that is for 3 is 150 to 500, 150 to 500. Here 100 to 400, 50 to 300. Corresponding that unit, FLAPC unit, you have to write this minimum and maximum. That is for unit number 3, 150 to 500. So here also you have to substitute 150 to 500. So unit number 1 is 100 to 400 megawatt. Unit number 1 is 100 to 400 megawatt. Next, unit number 2 is 50 to 300 megawatt. Unit number 2 is 50 to 300 megawatt. Like that, you have to write. This is the priority order. Next is unit commitment. So unit commitment, we have to go for the combinations. We have to go for the combinations like 3 plus 1 plus 2. 3 plus 1 plus 2 is minimum megawatt from the combination, maximum megawatt from the combination. Here unit is very, very important. Wherever we are mentioning the generating units, generating units, you have to mention in units. Okay, generation minimum and maximum, you have to mention in units, that is in megawatt or kilowatt, whatever it is given in the problem. Majority it will be in the megawatt only, so you have to write unit like in bracket. So again, while doing the unit commitment combination, minimum megawatt from the combination, maximum megawatt from the combination. So we have to go for 3 combination: 3 plus 1 plus 2. Okay, then 3 plus 1, then again 3. 3 plus 1 plus 2, then 3 plus 1, again 3 other. So this combination, what we have to do is we have to add 3 plus 1 plus 2. So 150 plus 100 plus 50. That is 150. 150 plus 100 is 250. 250 plus 50 is 300. Again, yeah, this is of minimum combination. Maximum combination, 500 plus 400 plus 300. So 500 plus 400 is 900, plus 300 is 1200. Here, next thing is that 3 plus 1, 3 plus 1, 150 plus 100, that is 250. Next here, 500 plus 400 is 900. Okay, again 3 alone already there, 150, 500 megawatt. Like that you have to do. So all three units would be held on until the load reached 900 megawatt. Okay, all the three units would be held on until the load reached 900 megawatt. Unit 1 and 3 would be held on until the load reached 500 megawatt. Okay, all the three units would be held until the load reached 900 megawatt. 900 megawatt. Units 1 and 3 would be held until the load reached 500 megawatt. Units 1 and 3 would be held on until the load reached 500 megawatt. Then the unit 1 would be dropped. Okay, so up to this you have to write 5 marks. 5 marks they may ask this problem. Only 5 marks they may ask for this problem. Very easy. Again, I repeat, what you have to do is from the given problem. Okay, the problem generating units is given, minimum and maximum, loading limits, operating limits also given, that is in megawatt. Then fuel cost like parameters is given, a b c is given, then fuel cost is given. So from that we have to frame the heat rate characteristics easily. We can frame the heat rate characteristics. So heat rate okay, heat rate um, uh, like this heat rate is being framed for three generating units. Again, we have to calculate FLAPC. First, we have to calculate FLAPC for uh, uh, three generating units, whatever it is given, by substituting PGI as PGI maximum value for each unit. So, what is the formula for FLAPC? FLAPC I is equal to KI into HI of PGI divided by PGI. So, here you have to substitute 1, 2, and 3. Okay, so meanwhile you have to substitute. Meanwhile you have to substitute by substituting PGI is equal to PGI maximum value. So PGI maximum value, whatever it is given, that you have to substitute. Okay, so after substituting, you will get FLAPC 1, FLAPC 2, and FLAPC 3. Next, we have to go for priority order. So priority order, what we have to do, we have to arrange FLAPC in ascending order. So ascending order means, so which is least has to come first. So here 3, 1, 2 is the ascending order, that is priority order. So that is corresponding FLAPC you have to write like 11, 11.99, 14.8. So meanwhile minimum and maximum megawatt also corresponding to that particular unit you have to write. You have to very careful. Corresponding unit, minimum, maximum megawatt you have to write. Next we have to go for unit combination. Unit combination you can easily go for 3 plus 1 plus 2, then 3 plus 1 and again 3L. So this minimum and maximum combination, which means that while combining all units, okay, so even minimum megawatts also it is compromising. Minimum megawatts from the 300 megawatts we can easily generate, we can easily manage this. Even 150 megawatt also, 100 megawatt also, 50 megawatt also, we can easily manage if we install with this combination. If you install minimum generating unit as 300 megawatt, we can simply manage. Okay, we can simply manage this three generating units. Say whatever it is coming, like 150 also you can manage, 100 alone also you can manage, 50 also you can manage. Next, maximum megawatt combination. Okay, so with this combination of this three generating units, you can easily manage 500, 500 megawatt, 400, 300 also you can manage, and even like combination also you can manage. If 500 plus 400 is coming, so that 900 also you can manage. Then 400 plus 300 is coming, 700 also you can manage. Then 500 plus 300, 800 also you can manage. Even with all the combinations you can manage. Next, we are going for 3 plus 1 combination. 3 plus 1 combination, here 250 megawatt. 250 megawatt also, if you go for whatever the combination, like 150 plus 100 megawatt. 150 plus 100 megawatt, 250 we can manage. Next, here 100 plus 150, that also you can manage. Like 100, 150 plus 50 megawatt, that is 200 megawatt, that also you can manage with 250 megawatt. Here also, if you see, like whatever the combination, like 500 plus 400 is 900, that combination, that is 900, we can manage. Next 500 plus 300, 800 combination also you can manage. Then 400 300 combination also you can manage, that is 700 megawatt also you can manage with this 900. So if you go for three third generating unit alone, like from this all these things, okay, this maximum, that is 150. Like if you, either if you go for 100 also you can manage with 150 megawatt, either 50 megawatt also you can manage with this 150 megawatt. So that we are going for 150 megawatt minimum combination. Here also, like a 500 alone you can manage, 400 alone, like already we have taken as 500, so 500 alone we can manage, 400 alone we can manage, even 300 alone you can manage with this 500 megawatt. So whatever the combination if you give, that has to, that minimum and maximum like megawatt generation has to be combined with this combination, that is minimum and maximum combination. That is whatever the combination you go, it has to manage. Like that you can go for changing the combination also, but this is the correct combination. Okay, if you change the combination also, it will not come. Like if you go for 2 plus 1, say for example wrongly you are writing as 2 plus 1, that combination you can't manage, that is 400 300 is coming. So again, if you go for like 400 300 is 700. If you go for this two, that is 500 plus 400, that is 900. That you can't able to manage with this 700 megawatt. So if it is maximum, no problem. It is minimum, then the problem will come, will arise. So this is the correct combination, so that you can whatever the combination you can go for, that you can reach. That's what they said it here. That is, all the three generating units would be held on until the load reached 900 megawatt. Unit 1 and 3 would held on until the load reached 500 megawatt. Then the unit 1 would be dropped. Unit 1 will be again dropped here. Next, example problem 2. Obtain the priority list for unit commitment using full load average production cost for the given data with the power demand as 550 megawatt. With the power demand as 550 megawatt. So we have to go for a priority list. Okay, we have to frame the priority list for demand of 550 megawatt. The heat rate for unit 1, it is given below, that is 510 plus 7.2 Pg1 plus 0.00142 Pg1 squared megawatt hour. Then for unit 2, H2 is equal to 310 plus 7.85 Pg2 plus 0.00194 Pg2 squared megawatt per hour. Then unit 3, H3 is equal to 78 plus 7.97 Pg3 plus 0.00482 Pg3 squared megawatt per hour. So first step we have to calculate FLAPC. FLAPC we have to calculate. FLAPC of I is nothing but Ki into Hi of Pgi divided by Pgi up to from I for I is equal to 1 to 3 or 1 to n, whatever the units we have taken. Substitute Pgi is equal to Pgi maximum for each unit. So for unit 1 we have to substitute I is equal to 1. So FLAPC 1 is equal to, here FLAPC 1. FLAPC 1 is equal to H1 into PG1, H1 into PG1 divided by PG1. K1 into H1 into PG1 divided by PG1. So we have to substitute PG1 is equal to PG1 maximum. So here minimum and maximum operating limits, maximum operating limits is given like 150 to 600 megawatt, 100 to 400 megawatt, 50 to 200 megawatt. So for unit 1 maximum is 600 megawatt. So you have to substitute 600 megawatt over here. So while substituting 600 megawatt over here, you will get one answer for FLAPC 1. That is 9.79. Next for generating unit 2. That is for I is equal to 2. We have to calculate FLAPC 2. That is nothing but K2 into H2 of Pg2 divided by Pg2, while substituting Pg2 as Pg2 maximum. What is Pg2 maximum over here? 400. So 400, you have to substitute it for H2 of Pg2. What is H2 of Pg2? H2 of Pg2 is equal to 310 plus 7.85 Pg2 plus 0.00194 Pg2 square. So we have to substitute Pg2 maximum. So what is Pg2 maximum? From this table, Pg2 maximum is 400. Pg2 maximum is 400. So you have to substitute 400 here, and fuel cost K is given, K2 is given as 1.0. 1.0 you have to multiply. So while doing all this calculation, you will get one answer, that is 9.4. Similarly for unit 3 also. Unit 3, I is equal to 3. So FLAPC 3 is equal to K3 into H3 of Pg3 divided by Pg3, where Pg3 is equal to Pg3 maximum. So what is Pg3 maximum? From the table given, Pg3 maximum is 200 megawatt. So 200 megawatt you have to substitute over here. And also K3 is 1.2. 1.2 is K3. That is fuel cost. So you need to substitute here in this H3 of Pg3. H3 of Pg3 is given here. You have to substitute the H3 of Pg3 here. So while substituting, you will get the answer like 11.88. So after that, you have to form the priority list, priority order. So what we have to do for framing this priority order, we have to arrange the all these FLAPCs in ascending order. So ascending order, if you sort now, first is FLAPC 2. Why? Because this is 9.4, this is 9.79, next is 11.88. So FLAPC 2 first, next FLAPC 1, then FLAPC 3. So 2, 1 and 3. So FLAPC 2 unit, FLAPC 2, 1 and 3. So that we sorted in ascending order. So ascending order. So FLAPC, what is the value of FLAPC full load average protection cost? Here first is 9.4, second is 9.79, third one is 11.88. That we substituted over here. So what is minimum and maximum power generation, that is megawatt, that is minimum and maximum operating limits, 100 megawatt to 400. So meanwhile for unit number 2, what is unit number 2? Minimum and maximum 100 to 400 megawatt. So 100 to 400. So unit number 1 is 150 to 600. Here unit number 1 is 150 to 600. Similarly unit number 3 is 50 to 200. So unit number 3 is 50 to 200. You have to substitute here. Okay, this is the priority order. So you have to go for unit commitment. Unit commitment, all the 3 units should be held until the load reached 1000 megawatt. So how we have to see, like whatever the combination if you do, that has to come. So here 2 plus 1 plus 3, then 2 plus 1 and again 2. Like that, if you take simply like that, that combination also optimal combination, it will come. The other combination if you also go for, but even after calculating, that will not satisfy. So whatever the 2 combination if you go for, that will not satisfy. So if you go for like simply like this, 2 plus 1 plus 3, then 2 plus 1, then 2 alone. Like that, if you go for that will become the accurate answer. What that combination will become accurate. It's like that, easily you can do. So this combination I am going for 2 plus 1 plus 3. So we are adding 2 plus 1 plus 3 minimum megawatt from that combination we are adding. So 2 plus 1 plus 3. So 100 plus 150 plus 50. That is 250, again plus 50, 300. So 300 I am writing here. So again maximum megawatt combination. 400 plus 600 plus 200. So 1000 plus 200. So it is 1200. Again 2 plus 1. 2 plus 1 combination, 100 plus 150. So that is 250. So 250 megawatt. So here 400 plus 600, 1000. So 1000 megawatt. Here I am writing. Next is 2. 2 alone already there. So 100 and 400 megawatt. So easily I can write. So all the 3 units would be held on until the load reach 100 megawatt. Unit 1 and 2. Unit 1 and 2. Unit 1 and 2 would be held. Okay, so unit 1 and 2 would be held until the load reach 400 megawatt, and unit until the road reached 400 megawatt, that is units 1 and 2 will be held until the road reach 400 megawatt. Then unit 1 would be dropped. Unit 1 would be dropped. Okay, next for unit 2 and 1 for 400 megawatt. So unit for 400 megawatt, unit 1 and 2 and 1 would be operating. Okay, so if you see here, whatever the maximum combinations, whatever the combination if you do, it will satisfy. If you go for 2 plus 1 plus 3, 2 plus 1 plus 3, here that is 300. So whatever the combination, like 100 plus 150 is 250, that also will satisfy here. So in 150 plus 50, that is 200 megawatt, that also we can so 100 plus 50, that is 150 also will be satisfying over here. So similarly like this, whatever the combination, 600 plus 400, 1000, so 1000 also it is satisfying over here. Next 600 plus 200 also, 800 also satisfying here. Next 200 plus 400, 600 also it is satisfying. So we are going for maximum combination. Like minimum, whatever it may be, that is not our problem. But maximum is our problem. Maximum is our problem. Next 2 plus 1, that is 250. 2 plus 1 is 250. So whatever the combination you can go for, that is 150 plus 100, that is 250, it is satisfying. So even any combination it will satisfy. So even 150 plus 350 also it is coming like 200. That also it is within the limit. 100 plus 50 also 150. That is also within the limit. But here the combination we have taken like 2 and 1. This combination also 100 megawatt also. This combination also will come under. Next 2 alone. 2 alone if you take. Okay, so 100 megawatt. So that combination also we can easily go for. So all the 3 units would be held until the load reached 1000 megawatts. All the 3 units would be held until the load reached 1000 megawatt. Okay, so up to this, okay, and also 2 and 1 would be held until the road reached 400 megawatt, and like then units 2 and 1 would be